Work. So good morning, everybody. Can you hear me? Okay. So I'm Dario Vianello. I'm a cloud bioinformatics application architect working in the technology and science integration team at EMBL-EBI. And I'll basically walk you through today in what we learned in more or less 2 years of experimenting with clouds in my institute. So EMBL-EBI is EBI stands for the European Bioinformatics Institute. We're part of EMBL, so the European Molecular Biology Lab, which is main outstation in Heidelberg, Germany. We are a bit more than 600 members now from 57 different nations, and we're also home of the Lixu Technical Hub that somebody mentioned this morning. Just going back to basics, so bioinformatics is the science of storing, retrieving, and analyzing large amounts of biological information. So from a very, very low point of view, EMBL-EBI can be seen as a massive number of these things. We're up to 120 petabytes now, accessed by storage system, so we are up to 200 racks now, and 40,000 cores scattered in different batch systems are accessing that wealth of information. It may seem a lot to deal with, so lots of cores with a lot of data. The reality is that, as everybody else, we're also computing and providing possibly services to the outside. So EMBL-EBI is that amount of data and a set of very complex services we are offering to the scientific community worldwide, more or less. Of course, we are using clouds, also clouds to do this, mainly private at the moment. We have several VMware clouds, and that's all our out-facing services. So all the VMs that are powering our services. And we have the Embassy Cloud, which is an OpenStack cloud that has now 11,000 vCPUs, has grown a bit since last year, with more or less 7 petabytes of storage exposed to it. Again, it may seem a lot, but the reality is that as everybody else in this room, more or less, we have the big data problem. So these are plots depicting the growth of data of 6 different data types we are currently storing at EMBL-EBI. And as you can see, they're all going up and not planning to come down anytime soon. But on top of that, because of the fact that we're offering services to the scientific community, we also have the big usage problem. So scientists coming to EMBL-EBI to get their data or their secondary information. And this is the plot of the web requests per day coming to our servers. There's a very nice peak January last year. Again, this is not going to come down anytime soon. So of course, something needs to change, because sustaining this, it's a bit of a complex task, right? And of course, you know, here comes the cloud. We can solve everything, just offloading everything, right? So why are we looking at clouds? Because as the amount of data each single scientist wants to compute increase, we want to have the community bring in their compute to our data, not moving petabytes every time, because that takes time. And hopefully not all their compute to our data center, because that's a bit of a long queue possibly. So what we are planning to do is to push relevant data sets, the one we know that people love, more or less, outside to cloud providers. EMBL-EBI Embassy Clouds, or our own OpenStack cloud, was the first step. Elixir compute platform Stephen was mentioning before, it's another step we want to take. Of course, EOSC again, Anno was talking about EOSCAP this morning, so the European Open Science Cloud will provide compute storage and a bunch of other services at some point to the scientific community in Europe. And of course, AWS, GCP, Azure, they're storing already some data sets in S3 buckets, and possibly we want to push our own little amount of data. Well, little is a bit of a small definition, I would say. And then what is going to come next, we don't know. And from a more, EMBL-EBI focused perspective, we want to basically optimize our capital expenditure versus operational expenditure, which layman's terms means we don't want to buy a massive amount of hardware to cope with peaks. The thing that usually happens just before Christmas, everybody submit your jobs to the cluster, because when you come back on the 1st of January, 2nd of January, the results would all be there. Okay, buying hardware to sustain that peak and then not use it during the year is a bit of a wasting money exercise. So if we can offload that peak somewhere else, that would be amazing. So during this experience, we identified a few science pain points. One is that science will likely need to adapt you can't run exactly the same stuff in the cloud. Data movement is challenging, and the procurement itself, so how you actually buy compute resources in the cloud is a bit lengthy and complex. So let's go back to the first one. So the way we tested this lifting a pipeline in the cloud was actually lifting a pipeline that was running on our own batch system at EMBL-EBI. We picked the marine metagenomics pipeline because it was a good candidate for several different reasons. And we used basically a combination of Ansible and Terraform and Ansible actually, given the order, to deploy a batch system in the cloud, and then we adapted the pipeline to run in the cloud. So we got rid of all the hard-coded paths pointing to storage system at EMBL-EBI, which of course are not available in Amazon, let's say. And we adapted it to pull and push data from FTP endpoints. So we pull the input from a public FTP endpoint, we push back the output to a private FTP endpoint. We did a bunch of scalability testing in Embassy Cloud, because Embassy is kind of free at the point of use, so we wanted to test we were doing the right thing. And then we ran the same stuff, the same input into 4 different clouds and compare both the running costs and the running times, and the costs. So the first thing we wanted to see was that, can we run as fast as on-prem in the cloud? So we ran those 4 ENA studies, ranging from 22 megabytes, admittedly very small, to 14 gigabytes, which is admittedly still very small, but it was the first step. Into Embassy, our own OpenStack, GCP Azure, and then we basically got the compute time on our cluster. So as you can see, for the first three, they're not very big, but the compute time is actually faster in our cloud deployments. And this is mostly due to scheduling, because clusters at the EBI, the batch systems are massive. So scheduling on 40,000 CPUs takes a bit more than scheduling on 640 vCPUs. As you can see, as soon as we go on the big ones, so the last 2, we see exactly the opposite trend. The cluster is much faster, but again, this is basically an artifact due to queuing time. When you try to match 40,000 cores with 640, of course, in the small cluster, you wait a little bit longer. Then, of course, how much did we pay? So we ran those studies with those number of vCPUs in these 4 clouds. For Embassy, we asked our cloud team to come up with the cost of running a vCPU on-prem. It's a bit of a very complex exercise. I don't know if you ever tried to do it, because capturing all the costs of running a CPU in your own data center takes an awful lot of time and is, to some extent, not always precise. But as you can see, I mean, comparing on-prem some Embassy to cloud providers, public cloud providers, we're talking about a different order of magnitude. So 0.77 versus 374, that's a bit of a different bill, right? But we also wanted to estimate what would have been the cost on spot market, which on GCP is called preemptible VMs, because they don't like to reuse names. And as you can see here, 374 on a normal VM, this is the first row, 139 on preemptible VMs, 0.77 on-prem. So the gap is closing quite a lot. We're almost in the same order of magnitude. So going to spot market is a bit of an additional technical challenge, but it definitely pays off if you can do it. So far so good, right? But what we realized very quickly is that pipelines must be deployed on demand as compute. There's no point in deploying a 1,000 cores cluster in 5 minutes and then waiting for 40 minutes for the pipeline to install in the cloud, right? So we realized, and that was the very beginning where we said, okay, we need to have DevOps but for ResOps, and that's where the ResOps adventure started, and Eric will give you a taster today in the afternoon. Sign up outside if you want. And the reason why you need ResOps is that clouds will move as the real ones. You'll likely be in an hybrid multi-cloud environment, because you may need to redeploy short notice, because Cloud 1 can be cheaper today, more expensive tomorrow, so your IT department may come along and say, okay, you know what, all the stuff you deployed in the last 6 months, move it somewhere else because the bill is becoming a bit too high. Second pain point, data movement is challenging. So moving petabytes isn't quite easy. It requires a lot of bandwidth, it requires a lot of time, even if you have a lot of bandwidth. It requires a lot of money, especially if you have egress charges. And it requires a lot of authorization to do so. What can I actually offload to a data center owned by somebody else? So to get at the bottom of it, we did a bit of a sampling at the EBI. So we went through all the type of data we store and hold the sensitivity level of all those data, and basically what were the storage options. And we came up with a very big matrix that says what we can move where. I don't have time to go through it now, but I guess you'll need to do the same at some point if you're looking at the same stuff. Procurement is complex. So benchmarking is the key here, because not all clouds are born equal. Even with those small input, you notice that the running time wasn't exactly the same. Price comparison is complex because there are different pricing models. You can pay per minute, per hour. There are different contracting models. Pay up front, pay per use, spot market, and post-award contract negotiation, which is basically the moment where your lawyers sit down with the cloud lawyers and try to decide on the contract. That takes a lot of time. It took 6 months for us in some cases, which is a bit of a long period. So we said, okay, let's start to address those challenges. Science will need to adapt. We do training basically now. So we take our scientists, we grab them in, we lock them into a room, and we teach them what we learned in the last 2 years. And this is exactly the ResOps training Eric will cover today. And we also try to lower those barriers through, for example, European projects such as Helix Nebula, the Science Cloud, and EOS Pilot. Data transfer is challenging. Well, we just need to rethink the way we do it. We can't move petabytes every time. We really need to move compute to data, not data to compute. And procurement is complex. We need to update the way we buy. So at the European level, Helix Nebula is trying to challenge this thing, to fix these things. It's a pre-commercial procurement where a bunch of procurers, CERN, for example, as basically committed procurement funds. We're talking about more than 5 million here. Manpower for testing and evaluation, and use cases with application and data and in-house IT resources, because we're talking about hybrid cloud here, right? To basically test services that cloud providers out there are building, and will basically result in services that will come online for the general public at the end of this year, more or less. And what we identified at the very beginning were what we called key challenges, which were data transparency layer. So how do we access the petabytes of data we have back in our data center in the cloud? How do we federate AI? So how do we authorize access to those data? And how do we update procurement frameworks? Because we don't want to basically use paper purchase orders, but possibly pay per use. They all sound a bit familiar, right? They were basically the challenges we identified running science in the cloud. The take-home message that institutional cloud usage is possible, is both a technical and a legal problem. You will need to talk to lawyers, that's for sure. We need to develop a shared language and understanding, because industry is not academia. And that's what Helix Nebula taught us since the very beginning. We spent an awful lot of time understanding, basically building a glossary, if you want. And we need to update the purchasing model, because purchase orders don't really work with pay-per-use. And that's me, thank you. Just to respect tradition, we're hiring again. It's the same basically slide I used last time. So if you want to be a cloud application architect at EMBL-EBI, that's the link. And it's closing on the 21st of January. So feel free to help yourself.
How much do you pay?
Well, you'll find it in the job post. Go and have a look.